So this is a short video showing piecewise function review. A piecewise function is simply two or more functions that are defined on different domains. We're going to graph more than one function on the same set of axes, and our key thing is that one function is defined for a certain domain or input, and another function is defined for a different domain or input. So I'm going to highlight this entire first thing in red, and I'm just going to write off to the side what you want your brain to see. So you want yourself to see y equals 1x minus 3 right now. So I'm going to graph that. Y equals 1x minus 3. It follows my y equals mx plus b. So you can say y equals mx plus b. Your slope is your 3. Your y-intercept is, or your slope is your 1. Your y-intercept is your negative 3. That means you start down here at negative 3, go up 1 and over 1. Now it's important to know that with piecewise, it's nice to be able to erase. If you're doing it digitally, you have to think a little bit farther ahead. So I know that this is defined on the domain of x's that are less than 1. So I'm just going to draw the entire line. I will be erasing most of it. And then I'm going to look at the x-axis. And I say to myself, well, 1 is right here. And if there's no y-axis, I know that I can see this pretty quickly that less than 1 would be to the left. So you do that visual shift and say, oh, everybody that I want is on the left side. So I'll just go ahead and put an arrow there. And this tells me that it's going to be a closed circle. Now, I'm on a computer screen, my iPad. I can erase this really easily. You would have either pencil, or if you're doing it on another digital platform, you'd have to have thought ahead for this. So that's where the digital platforms can get tricky. You might need a graph paper to do it first and then transfer. Now I'm going to switch over to blue for the second one. And this can be tricky because here we have y equals negative 5. You have to remember that that is a horizontal line, or you have to realize that it still follows y equals mx plus b. And in this case, it's just your y-intercept is negative 5. So this is like y equals 0x plus negative 5 or minus 5. So what that means is you have your horizontal line down here at negative 5. Well, I'm going to think ahead a little bit here and say, well, this is my point where it's defined. So x's are all greater than 4. That's where I want to look at this. So I'll go and kind of jump down and say we're doing an open circle because it's greater than. And we're going to graph everybody that's bigger than 4, so it would be to the right. Now, it's important with piecewise that you label them if you're not using a digital platform, so I will just call this 1 and this 2, and we could label it 1 and 2, or you could call them by their names. Let's look at another one. So the next one is 3x plus 10 for negative 6 to 3. So I'll highlight this in red. And this time I'm going to try to think ahead a little bit more, but I'm still going to use that y-intercept. So we'll have my 10, and it has a 3x. So I know that that would go up 3 and over 1, but I can't do that, and I don't even want the domain past negative 3. So I'm going to go down 3 into the left one. And what you'll see is I'm only looking for the domain from negative 3 to negative 6 on x. It's always the x line because the domain is your inputs. So I really only want to capture that piece of this graph. So it'll be right here. And I can erase those spots. And then I ask myself, well, am I going to have an open circle or a closed? Both of them are going to be open. So I will need to go back and erase a little bit more, because these are both open circles. So that is my function number 1. Let's just name it now while we're thinking about it. And now this one picks up at negative 3. Sometimes it's helpful to think about that ahead of time, and ends at positive 3. So again, this graph would be y equals x plus 4. So you have your y-intercept of 4. And then you're going to go up 1 and over 1. So I'm kind of paying attention to this domain here and seeing what's going on. Now what I notice is that this is kind of interesting because at negative 3, this new function picks up, but it's the same value as the old function. So they overlap right here. And then it stops up here at positive 3, and it is an open circle there. So I'm going to go ahead and connect these, and this would be choice 2 or function 2. And we'll go ahead and erase the domain line. We don't really have to. Let's try one more. This one, we have a similar situation where we have the domains given to us as a doesn't go on forever situation. It's just a little piece. So I'm going to take that top one and I'll do 2x plus 9. I'm going to think ahead. I only want to use the x's from -2 down to -6. So here I go. So I start up at 9 and I need to go up 2 and over 1, which the opposite of that will be down 2 into the left 1 to fit into that domain that I want. And I just keep going, and I'm only going to take the piece I want that's in that domain, so I need to erase this part because it's not, and then I'll connect. Once I connect, I have to look and see open or closed. On the bottom, I want open, so I can erase and change that to my eraser isn't working for me. Okay, we'll just change that to a big open circle, very obvious overdone open circle, and we'll label it 1 and try to figure out why we can't erase. There we go. So now I can erase my domain and change my open circle a little bit. And then the next one is f of x equals -x, another tricky one because your brain needs to think y equals -1x plus 0, or just -x plus 0, so it has a y-intercept of 0. So again, take that -2 to 4, that's your domain, and you start at 0 and go down 1 and over 1, and just kind of pay attention to that domain. You can erase a little bit less this way, and notice they're both going to be open circles again. I often don't think ahead enough there, and I always find myself having to erase. So they're both open circles, and you have a 2. So that would be a crash course review in piecewise functions. If you're using a digital platform, you want to consider using graph paper and graphing by hand, and then transfer, because the digital adds that element of having to think ahead that makes it a little bit harder in the moment. You can also, if you're doing something where you're submitting for a teacher, you could say, I'm going to do it all on graph paper and show it to that person in person instead of digitally.